Hello, this video going to find the volume of the solid generated when the region bounded by the curve and the line when it's rotated about the y-axis. Okay, let's look at this problem here. So we have two curves and one line, right? So as you have to sketch the curve to see where's the region that the question mentioned. So we have curve of y square equals to x, or x, you know that the curve for y square equals to x will be going this way. It's a parabola that open to the right. And y equals to x, y equals to 1 over x, it will be looking at this way, right? So it will be these two region for y equals to 1 over x, and the line y equals to 1 over 2. Right? Line equals to 1 over 2, but I don't put line y equals to 1 over 2 first because I'm not sure the line y equals to 1 over 2 is above here or below here or during this line here. We don't know, right? So we have to look at the graph carefully, as this is the graph for y square equals to x, right? Y square equals to x, and this is the graph for y equals to 1 over x. So we have to find the intercept point here. Means that the region bounded will not be in the third quadrant here. Alright. So I will specifically look at the first quadrant here because the line y equals to 1 over 2 is at this quadrant. Right. So then I have to find the intersection point between this curve and this reciprocal function here. So as I want to rotate through the y-axis, so the important here is I must find the y value here, right? I want to know the y value here. So I replace the x here with y to the power of 2, right? So I have y equals to 1 over x, equation 1, and y squared equals to x, equation 2. As I know that x is y to the power of 2, right? So I replace the x with y to the power of 2, and I have y cubed to be 1. Then if I solve, I have y to be 1. So it means that the y value here is 1. Right? The y value here is 1. Of course, if the y value here is 1, the value of y equals to 1 over 2 will be lower, right? It's somewhere around here. So this is the importance of finding this intersection point. So then you know that y equals to 1 over 2 means that there is a line. So this line here. So y equals to 1 over 2. Where is the region that bounded by these three, right? Of course, it's this one, right? This one, because it's bounded by these two curves, this curve, and this line. So this is the region that we want to evaluate, and this region is rotate about the y-axis here. So then specifically, I want to talk about how to rotate this region here. So we must define the volume, right? The volume. So the volume pi is integrate from 1 over 2, as this region you want to rotate through y-axis is from 1 over 2 up to 1, right? 1 over 2 up to 1, right? So which is far away from between y1 and y square equals to x. So which one is far away from the axis, right? Of course, the reciprocal graph, right? You see that this curve here, it will form a bigger solid. If you rotate this, it will form a bigger solid here. So you will form a solid like this, right? And you have to take away the solid here. You have to take away the solid. So it means that this is a solid form. So is I taking the bigger solid that after I rotate minus the solid of this curve when it's rotate, right? So then I taking the reciprocal graph, and I have to write this in terms of y equals to 1 over x. So I have to transform it to x equals to 1 over y, as I want to rotate about the y-axis. So, and for this, we have x equals to y squared, right? X equals to y squared. So I label this as x1 and I label this as x2. Okay, so now it's x1 square minus x2 square, or x2 square minus x1 square. So I have said this curve is far compared to this curve from the axis of rotation, right? So this curve, the name is x equals to 1 over y, which is x2. So I have to take x2 to the power of 2 minus away x1 to the power of 2 and integrate with respect to y, right? So, okay, I have integrated. So I have pi integrate 1 over 2 to 1 as x2 squared, right? x2 is 1 over y to the power of 2, right? x2 is 1 over y, then power of 2 minus with x1 squared. x1 is y squared, so you have to square again. So it means that you're taking the y squared, you have to square again. So now this is the most important one as you define the volume for this problem here. So let's calculate. We have pi integrate from 1 over 2 power of 1 over y to the power of 2, which is y to the power of negative 2, right? You know that you will need this when you integrate by using basic rule. So minus with y to the power of 4 dy. So let's integrate this and get the volume. So we have pi y to the power of negative 2, you have y to the power of negative 1 divided by negative 1, y power of 5 over 5 from 1 over 2 up to 1. So let's see what's the value you get. Alright, okay, you were getting negative 605 for this, negative 605, and negative, calculate with 0.5, you have negative 321 over 160, and negative 6 over 5 plus with 321 over 160, you are getting 129. The volume generated will be 129 over 160 pi unit cube. Alright, so the most important thing is the video. When you're watching this video, you have to see how I define this volume here, right? So as I take this, the curve here, the x square minus the x1 square here, right? Because this will forming a bigger solid, right? And for this, you will form a smaller solid. So you have to take the bigger solid minus the smaller solid. So I think that's all for this video.